Hello and welcome to the Drought Severity Evaluation Tool video demonstrations. This video focuses on case study number 1, which focuses on the topic of drought. As you have had the option to be able to download either the entire user guide PDF or a segment of the individual case study, it's suggested that you have open alongside your video tutorial the document to help you follow along through this demonstration. However, you also have the option to watch the video as we work through this case study together and then return again to run this analysis on your own at a later time. The purpose of the user guide and also the demonstrations that we are providing you through the series of videos is meant to help create a feeling that DSET is extremely user-friendly and will also help you save on downloading data and also time spent on gathering data to create an analysis. So let's begin this first case study. So case study 1 focuses on drought. So a couple of helpful tips. DSET is going to be best used on Google Chrome. The faster network you have, the better. And then also, if there's ever a time that we come across an error, to always remember that we have the opportunity to reset and to start again. And just a side note, as you're looking at your document that you've downloaded for case study 1, there's been sort of a color coding mechanism that has been developed to help link the colors of the text and sections of the DSET interface to the document to kind of help you give that visual link. So in this case study 1, focusing on drought, it's broken up into 2 sections. The first section is part 1, in which we will be looking at the daily precipitation for the northern water year. The second section is part 2, in which we will be looking at the drought index for the Navajo Nation. So now let's bring your attention here to the interface of DSET. So what you see on your screen in this video is what you should see when you click on the DSET website link. Our objective for this section is going to be to find the daily precipitation totals for the last northern water year across the Navajo Nation. So when we're going through this exercise, another note to mention is that as we move through and go through each of the steps, the figures that are included in each of the case studies are meant to help you associate the location on the DSET interface where you'll be able to find the variable or the data sets, the calculations, wherever the parameters you need to enter. So let's go to step 1 now. Let's go under layers. So each of these are features that you can click on to help you begin to create what you want to see on this map base that you have here. So for layers, we see that the Navajo Nation chapters is selected. And according to our case study 1 for step 2, that's exactly what we want, is that we want to have this clicked on to show the chapters. And notice if we unclick it, the borders of the Navajo Nation chapters disappear. So here we are turning on the Navajo Nation chapter layer. Now this here to the side, so you can either click on the base map itself, or you can click on the little exit box here to get rid of the layer descriptions, and that will apply to the rest of the other features here in this section. Now let's look to step 3 for case study 1. So we want to zoom in a little bit closer to the Navajo Nation boundaries to help us in limiting the amount of calculations that will be done during this exercise. Where you see my cursor on the right-hand side of the screen is where you can opt to zoom in or to zoom out. And then if you click on the map itself and you hold on the mouse, you're able to rearrange the placement of wherever you want the base map. All right, so now we zoomed into our Navajo Nation border. So moving on to step 4, where we will be clicking onto the map options. Now here, the map options provide a number of base map options that we can use. Currently, we're on the hybrid, but our exercise that we're going through for case study 1 asks us to click on roadmap. And so as we click on roadmap, we're able to see how that base map is changed. And so you can see with this kind of map, you can definitely see the distinct borders of the Navajo Nation, but also each of the represented chapters. So now let's get into working with this make map panel of where this will provide the map interests that we have for developing our drought analysis. So let's move into looking at step 5. So here on this make map panel on the left side of the web page, we'll click on the variable. So notice here that there's a visualization layer. You have two options, raster or average polygons. We'll go ahead for this exercise, leave this on raster. But now we're going to change a couple of things when we come to variable. And so if you ever have a question about any section or some of the data sets, the variables, you have this option, an opportunity to click on this yellow question mark. And this, by clicking on this yellow question mark, you're going to be provided an explanation of some information that is associated to whatever section on the Make Map panel you clicked on to get information. On step 5 for case study 1, it asks us to look under the variable section. See how in your document the variable is kind of a bright blue to match the bright blue color that we have here for variable? That's just to help you visualize some of the connections of where you'll look at to the document and then also to the interface to help you more easily find the section that you're looking for as you go through these case studies that we've provided you with this user guide for DSET. What we want to do for step 5 is change the type parameter. And instead of remote sensing, we want to look here at the climate hydrology. And for our data set parameter, what we want to change that to is to look at the Met data, grid Met data daily. You can see that there's a variety of data sets associated with different areas ranging from precipitation to climate to pre-computed, but we're interested for this exercise into the Met data, grid Met daily. So there we go, we have that data set. I'm gonna leave the precipitation here as is. We're not gonna change any of that. So we're moving down here to time period. And we're also gonna leave processing, as you notice. We're gonna leave it as total and the calculation as values. None of the steps ask us in case study 1 to change that at this moment. But now we're moving on to step 6, which looks at the time period. So time period, again, you can click on this, learn more about what this section is, but what the time period is going to help us do is select the date range. So the date range that we've mentioned a couple times now in this video is that we're interested in looking at the last northern water year. The last northern water year, you'll find by clicking here on this tab, so you see seasons, you'll click on this and look through, so it gives you a number of options that you can go through and create various analysis, but we're interested in the last northern water year. So the last northern water year is from October to September. So as we clicked on that, you'll notice that the start date and end date changed. And so the start date and end date for the last northern water year that we're working with currently is from October 1st, 2018 to September 30th, 2019. And as you go through a couple of the case studies, you'll find that when you're working with time period, it's definitely important to keep track of your start date and your end dates so that your analysis will run in the specific time periods that you're interested in. Again, this is the area that you'll also want to keep track of when you start to develop your own analysis, is that although the user guide that we've created for you, the PDF that we've developed, and also each of the appropriate segments that are broken up into the case studies vary in year, it might change for you when you run this analysis. And there's a bit more of an explanation of that in step 6. So now we're going to leave the rest of the information as is, and we're going to follow step 8 on case study 1 and click the Get Map layer. So now the process is being requested, and sometimes this might produce an error depending on the length of your analysis. But lucky for us, for this case study 1, it went through with no problems. We have no errors. So as you can see, the map that was created for us was based all on precipitation using the GridMet data set. And here you'll be able to see the scale of looking at the values for this particular precipitation variable that we're interested in. The precipitation here is listed in millimeters for us. Now let's take a look at the next step of what we want to focus on. So step 9 lets us know that we're able to use this feature here to change the transparency of our data. And so as you see, as you raise the cursor up, the map, the base map underneath disappears, but as you bring it down, it reappears. So it's up to you on how you want to work with the transparency that you're interested in. But for this exercise, we're going to leave it at 70% to be able to see a little bit of the base map, but also the data. So now under step 10, we see that our map should look like the associated figure. For this exercise, that is what you see here is the display of the precipitation of the last northern water year from October 1st, 2018 to 2019, September 30th date range. So now let's examine a little bit closer each value. And this is the cool thing about DSET is that we're able to look specifically at the Navajo Nation to find specific variables. And so by doing this, we can use this feature here. So where you see my cursor in the middle of the screen, there's this option called Get Value. So when we click on Get Value, you'll see this little red geotag pop up. And this is right here in your case study 1, step 12. You'll see a screen capture of the Get Value red geomarker there as well. So as mentioned before, for case study 1, we can look at individual chapters of interest for us. For this chapter, we're interested in the Selene chapter. What we want to do is, you have the option to move the geotag to different sections. So as you're moving the geotag, you notice that the latitude and longitude are also changing to wherever you're moving your geomarker. Let's look at the Selene chapter. However, there may be some people who don't know exactly where the Selene chapter is. You can click on any of these polygons and get the location of the chapter that is represented. So right here we have the Denahotso, we have the Ana chapter, but we're interested in the Selene chapter. So you see that this is what the chapter boundary that we're interested in is Selene. So now we can click on our Get Value and drag it there to the Selene chapter. We're in the Selene chapter boundaries. So moving on to step 13, we'll go ahead and click the Show Value. So while that processes, this is what's going to show up is the total precipitation for the last northern water year in that specific spot. And so that year, the last water year from 2018 to 2019 that we referenced, the total precipitation was 217.8 millimeters. So this result shows us how we can use DSET to show us the precipitation variable by using the MET data, GridMet daily data set for across the Navajo Nation as we've seen, but also to specifically look at an individual chapter. And so again, as you'll see in your case study 1, it's mentioned there after step 13 in the paragraph that the value found was 217.8 millimeters. However, if we just move slightly to the south and hit Show Value again, you'll notice that a different value may appear because the geomarker was moved. And so now we see for this spot, the total precipitation was 232.3 milliliters. And so it may vary inside a chapter boundary. The total precipitation amount and value may change, but if it's in the range of what we mentioned in the study guide, that's pretty close to kind of remind you that you've run through the study pretty seamlessly right now as we're going through this case study. So don't get thrown off too much on that number. Okay, so let's move on to the next step. Right now we're on step 14. So this is where we're gonna keep the variable that we have, data GridMet data set. So here we have that here, looking at the Make Map panel, we have the Met data GridMet data set, so daily, and then we have our variable precipitation variable that lists the precipitation here for us. And so note that in step 14, it tells us to leave it as is. So now moving on to step 15, we're going to change the processing a little bit now. So whereas before we left it as total and value, this time we're going to change the calculation to the percent of average conditions. So again, you got a number of options here that you can select. And again, you can click on that little icon there, the yellow question mark, and get more information about what each of these different calculations will do for you when you run your analysis. But for right now, we're interested in the percent of average conditions. So let's click on that. And then we're going to go ahead and keep the time period the same. We're interested in the last northern water year, so that's not going to change. However, you'll notice something a little different from before, whereas in developing this precipitation map that we have currently here for Selena chapter, we didn't have this option before, the year range for historical average distribution. But once we change this calculation per percent of average conditions, this has appeared. So this right here, we're going to leave it as default. And so the default for us is from 1981 to 2010. So we're not going to change anything, but just wanted to state that so you're able to know that that is a new thing. But for right now, for this section of the case study, we're going to go ahead and leave that alone. In step 17, it tells us to click the Get Map layer. So now we're going to click that and wait for our map to process. Again, it may or may not happen that you might get a server error or a time error. And if that happens, we just click the reset button here and start again. But lucky for us, again, our analysis has come through without any errors. So now let's take a look at what we've got here. Now on our map, what we see here is the precipitation percent of average by GridMet. And so this varies a little bit from what we saw with just looking at the precipitation totals. You're able to see how the scale has changed now, giving us different variables, or giving us different values rather, and then also giving us a different color scheme. So using the percent of average condition calculation takes the total percentage from the last 60 days and divides it by the average conditions. By dividing it by the average conditions, this is multiplied by 100%. And so that's how we get this percentage here. We're interested again in looking at the Selena chapter. So note before we got a variable to show us the total precipitation to be about 217.8 millimeters. So if we click here on the get value again, and we're still interested in the Selena chapter, we click the show value. This is going to give us another value, but this time it's going to give us a percentage value because we're using the percent of average conditions for our calculations. So the percent of average conditions, why are we using this? It's because that it's an indicator of drought conditions. So we see here for Selena chapter for the last northern water year, the value for the precipitation percent of average came out to be 116.03%. And if you move the geo marker around a little bit, this number might change some. So this value is just giving us one specific year, one specific water year, so essentially one specific variable that we've developed so far. However, if we look over a longer time period of these values, it could show us how these values differ from long-term drought. And that's an area of interest for us in this case study. To keep in mind that the percentage value in this case study exercise might vary a little bit depending on the year that you're running that percent of average conditions. Okay, this right here with this value and running through so far what we've done in DSET brings us to a close for part 1. So now we're going to move on to part 2, which is going to explain to us a little bit more about the drought index for the Navajo Nation. So for part 1, we primarily focus on precipitation, and now we're moving into part 2 of looking into the drought index. And so in part 2, our objective is going to be to develop a map displaying the drought severity on the Navajo Nation using the Standardized Precipitation Index. Again, that is also known as the SPI index. What we want to do is we want to reset our DSET interface here so that we can have a fresh start of developing our analysis again. So here we have the Navajo Nation and our chapters are already displayed. We don't have to really focus it on step 2 for part 2 because our chapters are displayed already, and we're already pretty much centered with having all of our chapters shown. So we have the satellite reservation chapter here, Alamo is displayed, all the way up to the Aneth chapter. So for step 4, we're going to change the map again, and we're going to change it again from hybrid to road map again. The Navajo Nation boundary displayed. So now we're going to move to step 5. And again, remember that just above step 5, if you're looking at your case study, moving along with me through this video tutorial and looking at your document at the same time, right above step 5, you'll see a figure. And that again is just to remind you that each of the steps are linked to each of the figures to kind of show you where to navigate on the tool if you just so happen to not be watching or not have the option to watch any of the video tutorials for whatever reason. You can also look to that figure for extra help. All right, so now we're at step 5 on part 2. So we're going to change the variable again, and we're going to look at the data set. We're interested at this variable section, and we're interested in not the chirps data set, but again, we're interested in using the metadata grid metadata. So there we go, we changed that. But this time, we're not interested in the precipitation variable. We're interested in the Standard Precipitation Index, SPI. So we're going to scroll all the way to the bottom to the drought indices. So that helps us complete step 6. Okay, so we have that ready. All right, so now we're down here to step 7 in part 2, looking at time period. So the season, again, that we're going to change and what we're interested in is the last northern water year. If you look at these options that we have here, you'll see that you won't see the option like we had in part 1 that gave us the option to select the last northern water year. So we don't have that, so that what we're going to do is we're going to use the custom date range. And so we know the dates of the last northern water year, and we know that the last northern water year for this case study started in 2018, October. So we have that October 1st. So we'll change that start date there. And again, to remind us, our last northern water year ended on 2019 for this case study on September 30th. So we're going to change that date as well. All right, so we have September 30th. So there we have displayed, we entered it manually into the custom date range to put the last northern water year. So now we're going to leave this year range for historical average distribution as is, and we're not going to change anything else. According to part 2, step 9, we're all ready to click the Get Map layer. So waiting for it to process. Again, if at any time you should receive an error, you just go ahead and click the reset button and then run the same analysis again. But again, our analysis came through without any error. So here now, you'll see the displayed information for the Standardized Precipitation Index, SPI, for the last northern water year. So you can see in some areas on the Navajo Nation that there was this red color. So if you haven't worked with SPI before and you're not really familiar with some of what those values mean, there's a helpful feature here in DSET that you can use. And so if you follow my cursor here next to the SPI values that are displayed right above the map, again, there's that option there with the little question icon in the yellow circle. You can click on that and you'll see the US drought monitor categories. And so each of those colors that you see there that are shown as the values are able to show you what they mean. So for example, for the last northern water year, we see that red color there. That means that area of the Navajo reservation was experiencing an extreme drought. However, if we look to like that blue area here, we see that that is describing to us to be an extreme wet conditions. Okay, so then again, you can either click the map or you can click that little exit box there to get rid of that legend there for the values. Again, just to bring your attention, you can change the transparency here to whatever you would like to use. For this example, we're leaving this on 70. Okay, so what does the SPI indicate for us here on this map that we've developed? What is shown here is that the majority of the Navajo Nation was in some type of drought for the Navajo Nation. And there again, you see the variables there. And we can use the US Drought Monitor classification to be able to describe what we see here in terms of looking at exceptional drought, extreme drought, severe drought, to be able to start to develop an analysis for each specific chapter region. And so that's what we're going to do in this next step. So this map here shows us the overall generalization of the SPI values for the last northern water year. But say, for instance, we were just interested in the drought condition SPI value for a specific chapter boundary. We can do that as well in DSET, and that's what we're going to do in these next few steps, is be able to create a map to show us how to develop an SPI value for a single chapter area. So right now, we're going to reset our map again. So there we go, we click that, and our map should reset. Okay, so it brings us back to that interface of as if we just opened up the DSET tool. Okay, so now what we're interested in is changing the map the base map again, but this time let's try to look at the light political scale. So it's slightly different from the road map. It has a similar color scheme, but it's slightly different. And that's linked to step 12 on part 2 of this case study. Okay, so now let's look at our make map panel here. And what we're going to do again is change our visualization layer. So whereas before we left it as raster, now we're interested in looking at polygons. And so these are all different polygons, these various shapes that outline the chapters. Those are the polygons that we're interested in. And so instead of just having it flow over the data flow over seamlessly throughout the whole Navajo Nation, we're just interested in specific polygons. And that's what this feature in the visualization is going to help us do. Now, as we switch from raster to average polygons, you know that we're presented with more options. Again, just to refer back to the case study document, you'll notice again a figure above step 11 that breaks down each step that is linked to each feature on this DSET interface. We're on step 13 and we're interested in this visualization layer. So we've already changed it to the average polygons, but now we're interested into, we'll leave the US region, but we're interested into this Navajo chapters. So you could look at either the polygons for the agencies on the Navajo Nation, the mountain ranges, or the Navajo Nation boundary as a whole. But for this part of case study 1, we're interested in looking at chapter polygons. So we're going to change that, leave that as the chapter polygons. And we're going to come down here to variable. So this is step 14 and part 2. And we're looking at the data set again. So instead of having a variety of options like we've seen before, we have 2 options here. So we have the CHIRPS data set and we have the GridMet SPI. And so we're interested in drought right now, looking at the SPI values. So we're going to click on GridMet SPI, and this is pre-computed. So here we've clicked on the GridMet SPI, and we're interested in 6 months. So it gives you the variable options of 3 months, 6 months, 9 months, and a year, 12 months. But we're interested in 6 months. And as you notice, 6 months was the default, and we're going to leave it as the default. We're moving on to step 15 in part 2. We're going to leave processing section alone for right now, and we're coming straight to the time period. So we're looking at this time period, and As you notice, you don't have the option to change the start date right now. We're going to leave this as is, and we're going to change the end date. We're going to leave this as 2020, but however, according to our case study, step 15, we're going to change the end date to January 1st. Okay, and so as we've changed that to January 1st, 2020, you'll see that our 6-month time period start date changed as well. And so this matches up with our exercise that we're working on, bringing us to looking at the dates between July 1st, 2019 to January 1st, 2020. Okay, so now we've done that, we've changed our time period. We're gonna leave all of the other sections alone, and we changed what we needed to change so far. So now we're going to click on the Get Map layer. Again, if you should get any kind of error, you have the option to reset, but we've done good so far. We haven't got any errors, so we're good to go. So now you'll see that the data represented in this map is different, whereas before we had data stretching all across outside the Navajo Nation boundary that was presented. However, now we're just focusing on data that is presented for each of the polygons. And each of these polygons represents a chapter, again, to remind us that there's chapters represented by each of the polygons. The color schemes that are presented here for each of the polygons, they still follow the U.S. Drought Monitor categories, ranging from exceptional drought to exceptional wet years. Again, you can click on any of these to get information. So for our interest for this case study 1, we're interested in looking at the NAYIZA chapter. This is step 18 in part 2. So if you don't know where the NAYIZA chapter is, you can kind of click around until you find it. However, you'll notice that it's pretty handy in the section for part 2. There's a figure right below step 18 that shows you exactly where the NAYIZA chapter is. Here we go, we click on this, and that's going to give us the NAYIZA chapter. Okay, so this is the NAYIZA chapter. So now after clicking on the Get Map layer in step 17, part 2, you'll see that the map looks different, whereas before the data for the SPI was across areas outside of the Navajo Nation reservation boundaries, but now using the average area polygons, looking at the 6-month SPI, the values are isolated to each of the polygons. And although the values of the SPI are isolated to each of the polygons, it still follows the same categories that are represented by the U.S. Drought Monitor. You can see the general trend of the overall SPI for the 6 months for the Navajo Nation at the time we were interested in for the last 6 months of the SPI. And if you click on one of the polygons, you'll also notice that by clicking on one of the chapter polygons, you'll see the 6-month SPI value in a number form, not just described by a category, but you actually see that it's negative 1.538. And so as we've mentioned before, that's a sign of extreme drought by that number. So that is just another neat feature that DSET has that we can look at. Okay, so now let's consider looking at the same data set, but changing the variable now to 12 months instead of 6 months, and see how changing the time period will also change the overall trend of SPI values for the average area polygons that we've just created. So again, just taking a mental note of the extreme drought conditions across the Navajo Nation, ranging mostly over all of the chapter boundaries, and also the severe drought conditions, and then even the abnormal dry conditions. And you'll notice that the Alamo chapter is the only chapter that is considered to be in a moderate wet condition concerning the SPI values for this last 6 months in this case study example that we've just developed. But now let's change this to 12 months to see how that will change for us. We'll go ahead and just leave everything exactly the same, but now we're going to use 12 months. And again, as mentioned before, you'll just have to be mindful of your time periods that are done so that you're looking at data in the same interest of time that you were looking at for your time period that you've begun to develop in your analysis. So for us, our end date for this part of case study 1 was created to be on 2020 January 1st. So there again, we changed that. And now let's go ahead and hit the get map layer. So now we see how the values have changed for our categories using the US Drought Monitor, otherwise known as the USDM values. Whereas before, for 6 months, we just seen that there was just a great amount of extreme drought. But now looking at the 12-month SPI, for the same variable data set conditions, just changing the time period, are able to see now how those values have changed. So let's click on Red Mesa again, like we've done previously. If you recall, at the 6-month SPI for this chapter, Red Mesa, it was negative 1.5. However, now for the 12-month SPI, it is 0.2, bringing it to what is considered a abnormal wet condition for the drought category. So now taking into consideration the average SPI values for the 6-month time period and the 12-month time period for each of the chapters, we're able to see just how drought varies across the Navajo Nation depending on the time scales that we're interested in. So when you're making your own analysis and developing your own questions of how you'd like to use DSET to monitor drought, just keep in mind of just how time plays into the SPI values, like we noticed for the Red Mesa chapter in this example, going from the 6-month SPI value of negative 1.5 to the 12-month SPI value to 0.2. And so analyzing drought on multiple timescales can really help managers understand the differences in short-term versus long-term drought. Looking at how these drought conditions, there's either a deficit in precipitation, which can impact water conditions, or under prolonged droughts, like a hydrological drought, the impacts may be observed on the soil moisture or groundwater levels as well. So with this 12-month SPI grid map value that we've created for this map, this brings us to a close for our case study 1 that has been developed for DSET, looking at drought conditions on the Navajo Nation.